today we're going to learn how to find coordinates. So for coordinate geometry, we can actually find coordinates by using midpoint or using axes or using simultaneous equations. So let's have a look where we have a choice of using the midpoint. Now sometimes you may be given that you have a rhombus, and why is it that we can use the midpoint? It's because of the property of a rhombus. Now if you actually draw the diagonals BD as well as AC, you will realize that you will actually meet in the center, and this is your midpoint. So the midpoint of BD is M, but the midpoint of AC is also M. Alright, now in this case here we have 3 coordinates, but we have to find one more. Alright, so let's just call this as X and Y. Now what we can do is using B and D, we can find the M coordinates using the midpoint formula. Alright, so M is x1 plus x2 divided by 2 and y1 plus y2 divided by 2. So in this case here, we'll be able to get it as 1, and here we can get it as 0. So the midpoint is actually the coordinates 1, 0. Now since we know that M is the midpoint, if we take x, add to 9, and we divide by 2, it should give us the same coordinates here, alright, which is 1, 0. So what we can do is that now we can take x plus 9. When I divide by 2, I must end up with 1, alright. So what I can have is that x is equals to 2 minus 9, which will give me negative 7. Same thing for the y. Y, when I add to 6 and I divide by 2, must give me the y value of the midpoint here. So I have y plus 6. When I divide by 2, I must end up with 0. So I will have it as y is equals to 0, because 2 times 0 is 0, minus 6, and I'll get it to be negative 6. So what does this mean? This means that my A coordinate is negative 7, negative 6. Now, how about if we are asked to find coordinates and we are supposed to find the coordinates using the axes? Now, what kind of question would that be? Alright, so it may be a question like this. Okay, so they have already told us that the perpendicular bisector of the line joining A and B intersect the coordinate axes at P and Q. So we can say that maybe P is the one that cuts the y-axis, and the Q is the one that cuts the x-axis. So we're supposed to find the 2 coordinates. Now in this case, what we have to do is we first have to find that equation of the line such that it will be where P and Q lie. So the clue is given here, the fact that this is a perpendicular bisector. So when we want to find the equation of a perpendicular bisector, this will be in the form of y equals to mx plus c. So we need to have the gradient of the perpendicular bisector as well as one of the coordinates to use so that we can find the c, which is the y-intercept. So this is how it will look like. Given A and B, this is going to be the perpendicular bisector. So this is the one. Okay, so we will first have to find what we call the midpoint, because the perpendicular bisector will cut the center at 90 degrees and thus splitting the line AB into 2 equal parts. That's why it's called a bisector. So we notice that this is a 90 degrees here. Alright, now the 2 coordinates that we have are A and B, which means that we can find the gradient of AB and use it. Okay, so we can do the first step, which is finding the gradient of AB. So we can apply the gradient formula, y2 minus y1 over x2 minus x1. And this will give us 8 over 4, which is the gradient of 2. Now, since this one here, right, the gradient is actually 2, it means that this is my perpendicular gradient. So my perpendicular gradient, you can just take the reciprocal and you take the opposite sign. So in this case here, what I will have is that currently I will have y equals to negative half x plus c is the equation of my perpendicular bisector. So now I need to find the y-intercept, I need a coordinate which is going to be the midpoint here. So which means that I need to find my midpoint as well. So similar to the previous example, I have x1 plus x2 divided by 2. y1 plus y2 divided by 2. And my midpoint will be 4, 5. Using 4 and 5 and replacing them in here, I should be able to work out my C value. So I will have 5 equals to negative half times 4 plus C. And I will be able to get C as 7, meaning that my equation will be y equals to negative half x plus 7. So this is the equation of my perpendicular bisector. So since we have already deemed it to be that P is the point that cuts the y-axis, so what we can do is that at y-axis, right, my x value is 0. So which means that my y is equals to 7. Therefore, my P coordinate will be 0, 7. Now, at the x-axis, conversely, we have y is equals to 0. Alright, so what we will have is that 0 is equals to negative half x plus 7. So half x is equals to 7 and x will be equals to 14. So this means that my Q coordinate will be 14, 0. So this is making use of the coordinate that lie on the axis. Now the last case would be where we have to use simultaneous equation. And it will be a case like this. Now, you are asked to find the coordinate of C. Coordinate of C, right? There is no midpoint that we can use to find C. And C is also not lying on any of the axes. However, in this question, they have given us two helpful hints. C lies on this line here, which is y equals to half x. And BC is this equation y equals to 3x minus 15. So what you will notice is that this equation and this equation, they will actually intersect at C, meaning that we can use simultaneous equations. So the first thing we can do is that let y equals to half x be the first equation. Then we can have y equals to 3x minus 15 as the second equation. And we sub 1 into 2. And we'll be able to have it as half x equals to 3x minus 15. And we times 2 throughout. Okay, it's just so that we can get rid of the half, the 2 here. So we can have it as x equals to 6x minus 30. So we do a little bit of manipulation. 30 is equals to 60 minus x. And we'll have it as 30 equals to 5x, which means that x is equals to 6. So once we have this, alright, we can put it back into equation 1. So y is equals to half times 6, which will give us 3. Therefore, the coordinate of C is 6, 3. So when we run out of options, we can't use midpoint, we can't, it's not on the coordinate, on the axis. So C has to be found by simultaneous equation, which is the third way.